So we're going to talk today about the last method for solving systems, right? And one thing to understand is that math people don't get real creative with how they name things, right? So that this method is going to be called elimination, all right? We'll get back to what I was talking about in just a second. But so the objective today is to be able to use elimination to solve systems. Here are the standards we're going to hit. But what I mean by that is there are three methods to solve a system, right? And the names of the methods are going to tell you exactly what you need to do. So if we ask you to solve a system by graphing, that means you're going to need to graph the two lines and see where they cross. If we ask you to solve a system by substitution, that means we're going to ask you to substitute in for x or y. So we have to know what x equals, we have to know what y equals. If we ask you to solve a system by elimination, then that means we're going to have to, yeah, you guessed it, eliminate something, right? So here's how we're going to eliminate something. So the process here, number one, line up your variables. Now, again, this is very different than graphing or substitution in that if we're graphing, we're trying to get it in slope-intercept form, which means we're trying to get y by itself. If we're doing substitution, then we're trying to get one of the variables by itself so that we can substitute that into the other equation. But here, we want the variables to line up, right? We want the x's and y's on the same side, and we want them in columns. Okay, we want the equal signs in the same column. And then we want some constant on the other side of the equal sign in a column. So everything needs to line up in columns, okay? And then you're going to pick a variable to eliminate, and you're going to hopefully at the end of this be able to pick out pretty quickly which variable it might be the easiest to eliminate. But we're going to eliminate a variable. That's the elimination part. How do we eliminate the variable? We're going to make the coefficients on the variable you choose the same but different signs. So opposite. I'm going to keep saying opposite. Make the coefficients opposites. Same number, different signs. Okay? And we're only allowed to use multiplication to do that. Okay? So we're going to use multiplication to make sure that one of our variables' coefficients are opposites. Same number, different sign. Once that happens, we're going to add the two equations together. And what you'll notice is that the adding of those two equations together is what's going to eliminate one of our variables. And then we're going to solve for the remaining variable. Okay? And once we have that numerical value for x or y, then we can plug that in to one of the original equations and find the other one. Okay? So we're going to do a little bit of substituting in this method, but we're going to eliminate a variable, and that's why it's called elimination. All right, so how's that going to work? First example here. So the first thing you got to do is make sure your x's and your y's are lined up. You can see here, x's are lined up, the y's are lined up, the equal signs are lined up, and the constants lined up. So everything's lined up, which is good. Now, we want to pick one of our variables to make them opposites. Same number, different signs. Well, if you look here, the coefficients on these x's are 1s, right? So -1 and +1. So our coefficients are already same number, different signs. So we don't have to worry about using multiplication to make that happen. They're already opposites. Since they're already opposites, we're going to go ahead and add these two equations together. And look what happens, right? If I add -x plus x, I have to add like terms. If I add -x plus x, we get 0. Or if you want, 0x, right? But 0 times x is 0. So we can write down the 0. 2y plus 6y is 8y. And -8 plus -16 is -24. Now, 0 plus 8y is just 8y. So now one of our variables has been eliminated. Now, it's pretty easy to solve for y. Just divide by 8. And y is -3. Okay? Good. Now that we know that y is -3, we know that the solution to a system is an ordered pair, is a point. So we need an x value to go along with that. So I'm going to take this -3, and I'm going to substitute in for this y. Okay, so we get -x plus 2 times -3 It's equal to negative 8. So negative x minus 6 equals negative 8. Add 6 to both sides. And we get negative 6 equals negative x equals negative 2. And then divide both sides by negative 1. And so x is 2. So we think our solution is 2 common negative 3. And of course, we're going to want to plug that in to check to make sure that we're right. I'll do that really quickly for this first one, and then I'm going to leave the checking up to you. You need to check them all the time. So plug in 2 for x. So negative 2 minus 6. So plug in 2 for x, negative 3 for y, equals negative 8. This is definitely true. Negative 8 does equal negative 8, so check. We're good there. Into the other equation, we're going to plug in 2 for x, negative 3 for y. And when we do that, we get 2 minus 18, which is negative 16 equals negative 16. Okay? So, check, work. 2 common negative 3 is the solution. All right? But anyway, bottom line for elimination, get one of your variables to be opposites. Add the 2 equations so that the opposites will add to 0, and then you can solve for the remaining variable. Okay? All right, we can take a look at another one. Sorry about that. Number 2. Now, number 2 is a little different. Because if you look, our x's and y's and equal sign and constants are all lined up, and that's perfect, but we don't have opposites for either one of our 2 variables. So you look at this and you try to figure out which variable is easier to make the coefficients opposites. For me, it's going to be easier to make these 2 y coefficients opposites. You can make the x coefficients opposites if you want. But for me, making the y coefficients opposites might end up being easier. Now, how do we make them opposites? And again, going back to your steps, we are only allowed to use multiplication to make the coefficients opposites. Right now, they're not. This one's negative 3, this one's positive 6. So the question becomes, what do we have to multiply into these 2 coefficients to make them opposites? And sometimes you do have to multiply both of them by something. Here we don't, though. A way to look at this is what's the least common multiple between 6 and 3? And the answer to that is 6, right? Which this coefficient already is. So we don't have to worry about messing with him at all. This one, though, needs to become a negative 6. Needs to become 6 here, negative 6 if you include the minus sign. To make this guy a 6, I've got to multiply it by 2, which means that in order to keep the equation balanced, I have to multiply everything by 2. So I distribute this 2, right, and I get 4x minus 6y equals 16. And then what I'm going to do is I'm just going to kind of draw a line through this equation so I don't try to use it later. Okay? Don't want to mark it out completely because I might have to go back and check my work or go back and find a mistake if there seems to be one. Okay? Now, add your 2 equations. 8x plus 4x is 12x. 6y plus negative 6y is 0. So we eliminate that y. 32 plus 16 is 48. And divide both sides by 12. And so x is 4. Since x is 4, we can substitute that in for any x we want. And we're going to want to do that so that there's a y in the equation. So I'm going to be consistent and just keep plugging it in to this first equation. So I'm going to get 8 times 4 plus 6y equals 32. 8 times 4 is 32. Subtract 32 from both sides. And you get 0, so 6y equals, this is 0 also. Divide both sides by 6, and y ends up being 0. at which point the solution seems to be 4 comma 0, at which point you're going to want to substitute that back into the two original equations and make sure that that works for both. All right? But it will if you go through and do that. All right? All right, so now you try. Here's one for you. Make sure the variables are lined up. Pick one to eliminate. Make their coefficients opposites. Add the two equations, and then go from there. Okay? Stop the video, give it a shot, start it back up, and see if you get it right. Okay, this is what you should come up with. Did you get 3 comma 1? Okay. Now, how? I made the x's opposites. If you made the y's opposites, then you're going to want to go through and check your own work. It's going to be kind of tough for you to do that. But I thought it would be the easiest to make the x's opposites, and you do that by multiplying the second equation by 2. Okay? And then you can kind of follow the work from there. You get this equation when you do that. You add the first and the second equation together. 6y equals 6, divide by 6, y is 1. Then we go back up and substitute y in for 1 in for one of the y's. I did it in the first equation. You can certainly do it in the second equation, and that's perfectly fine. And you solve that down to get x is 3. Okay? All right. Got some more practice here. So try 4. Again, stop the video, work it out, and then start it back up again and check your work. Actually, I might walk you through this. So our variables are lined up, no problem. Now, we got to pick one of our variables and make them opposites. Now, for me, the x's are going to be the easiest ones to make opposites. So what's the least common multiple between 3 and 2? Answer to that is 6. So I've got to use multiplication and make both of these guys 6, and one of them negative. So that means I've got to multiply the 3x by 2 and multiply the negative 2x by 3. So like I said before, you might have to multiply both equations by something. Okay? Now if you do that, you will get, in the first equation, 6x plus 10y equals negative 32. And then negative 6x plus 18y equals negative 108. Add up your equations. You get 28y equals negative 140. Divide both sides by 28, and y is negative 5. And now that you've got negative 5 for y, I'm going to change it up and substitute it into the second equation this time. Don't get too weirded out. Okay? And then we get negative 2x minus 30 equals negative 36. Add 30 to both sides. Divide by negative 2. And so you get 3 comma negative 5. At which point you're going to want to plug those back into the original 2 equations and make sure that they work. Okay? All right, here's one for you to try. Number 5 here. Again, stop the video, see if you can't figure it out, start it back up, and see if you're right. Okay, you should have gotten this. So it should be 2 comma 0. Usually write these ordered pairs in alphabetical order, so 2 comma 0 should work fine. Okay? All right. Here, the trick to this guy was you had to multiply one of the equations by a negative number so that you could make your coefficients opposite signs, and that's fine too. Okay, but you had to multiply the first equation by 3 and the second equation by negative 2 to make those a's opposite. If you chose to make the z's opposite, then obviously it would look a little bit different. Okay, but you should still get to the same answer. Okay, try this guy and see what happens.